Well, welcome back to chapter 16, and this time we're talking about acid dissociation constants, and we're going to deal with weak acids and weak bases. There is already a video up on calculating the Ka of a weak acid and the pH of a weak base, and I'll fit those in where they belong. First of all, acid dissociation constants, Kas, they're just equilibrium constants, guys, nothing more than that. Dissociation is a reaction subject to equilibrium like any other equilibrium. Reactants decompose or dissociate into products, and at some point the rate of the forward reaction is equivalent to the rate of the reverse reaction. So we generally describe acids, especially weak acids, as just HA. It's a matter of simplicity. We don't generally care about the anion unless we're specific about caring about the anion. So in this particular case, here's our equilibrium. The acid in the Bronsted-Lowry sense is donating a proton to water. Water is acting as the Bronsted-Lowry base, accepting the proton, forming the hydronium ion. Now, in reality, we generally sort of ignore the water with respect to this, just as a matter of simplicity. It's not going in the equilibrium constant expression anyway. It's a pure liquid, so we generally will simply write the equilibrium reaction as Ka is equal to H plus times A minus divided by the concentration of the weak acid, and this would be our equilibrium constant expression. We understand that water's there, but for simplicity's sake, we just exclude it. All right, so I was drawing on this before. So let me just bring all of these guys up. Perchloric acid is a strong acid. It effectively ionizes completely with a Ka of 10 to the 10th. Considering that it ionizes so completely, we ignore the Ka. You can tell what the concentration of the H plus is in, let's say, a 0.1 molar solution of any strong acid. You simply assume that it's 0.1 molar in H plus, take the negative log of that, and you get your pH. Same thing for HCl. 10 to the 7th, so perchloric is slightly stronger than, well, actually it's 1,000 times stronger than HCl. This is iodic acid. This is the iodate ion. It's a 10 to the minus 1 acid, so it is a weak acid. It's got a Ka less than 1, so we do consider it to be a weak acid. Now, your first weak acids here we really will work with a lot are hydrofluoric, 10 to the minus 4, hypochlorous, 10 to the minus 8. We'll do calculations with both of those weak acids at some point in time. So weak acids, the Ka values are less than 1. They only partially dissociate. They're weak electrolytes. And weak acids exist in equilibrium with their ions. This is going to be our equilibrium constant expression along with the Ka. We could use the hydronium ion, but this is just much simpler. Let's take a look at a few examples real quickly. All acids in this course are weak unless they are one of the 7 strong acids that we've specified. That's a Chem 1 skill. You are supposed to know your strong acids. I think most of you do. Examples of weak acids, HF. If you have other weak acids are acids like hydrocyanic acid. This is hydrogen cyanide dissolved in water. It does partially ionize, and it's terribly toxic stuff. It used to be called prussic acid. So hydrogen cyanide or hydrocyanic acid was called prussic acid, and most people don't use those terms, but I found in agriculture, my brother, he raises cattle and hay, and so he calls hydrocyanic acid prussic acid. And so that was an interesting conversation I had with him. Farmers do an awful lot of chemistry. So if you're going to be a farmer, Well, there you go. You're going to do some chemistry if you're going to be a good farmer, and my brother happens to be a terrific one. So this is hydrosulfuric acid, and it's not sulfuric acid, it's hydrosulfuric, and it actually has the shape of water. It's H2S. It has this angular shape hooked up to sulfur over here, and so it's a weak acid, so it'll partially ionize. Then we have hypochlorous, nitrous, phosphoric acid. You're pretty much, as long as you know your 7 strong acids, you will be able to identify a weak acid. Here are some organic acids, and they are what we call carboxylic acids. Carboxylic acids have this feature, the COOH, which in the Lewis structure for COOH is actually what you see here. And so these are weak acids. They partially ionize. You actually have carboxylic acids that exist biologically in the form of amino acids. There is a carboxylic acid group on all amino acids. And so at any rate, this is how you recognize it. This is acetic acid, the active ingredient in vinegar. But this is the Lewis structure for it. You usually just see the formula. So recognize COOH as a carboxylic acid. Now you have this calculation for the Ka of weak acid already on video, so you will be able to watch that video after this one.